Okay, so today we're talking about three things. Position. Position is where you're at, where you're located, where your current position is, where location-wise, right? What's your position, right? You hear that a lot in the military. What's your position? That means where are you located, okay? Sometimes they'll call that, so we're not going to see a lot of f of x's. We're not going to see a lot of g of x's on this. We're going to see a lot of x of t or s of t. The t means time. The t means time. S, I don't know why they use s for position, but yeah. Velocity, what's velocity? See, so that's the answer I get a lot. Like, velocity is how fast something is moving, right? Then what's the difference between speed and velocity? Why did we say speed sometimes and velocity another?
Velocity like a rate or something?
They're both rates. Velocity and speed have the same rate. In your car, it's miles per hour. Okay? What's the difference between velocity and speed?
Can't be negative.
There it is right there, right? It's right there. Velocity, or the other way around, speed can't be negative. Speed's always positive. Okay? In your car, when you're driving, you look at how fast you're going, right? It's always positive. There's no negatives. Even when you're going backwards, it's always positive, right? That's speed. Velocity can be negative. How is it negative? Based on which direction you're going, right? If you're going in the negative direction, it's going to be negative. If you're going in the positive direction, it's going to be positive. So speed and velocity are the same thing when they're both positive. When velocity is negative, they're opposites of each other. Okay? What's acceleration?
How fast something is speeding up.
There you go. How fast you're picking up speed, or how fast you're losing speed, right? If you're driving 50 miles an hour down Herndon, just 50 miles an hour, your velocity is 50. Your speed is 50 miles an hour. But what's your acceleration? 0. Why 0?
Because you're not increasing.
Not increasing, not decreasing. I'm not slowing up, I'm not speeding up, I'm not slowing down, right? So that's acceleration. You pick up acceleration when you're getting on the highway, right? When you're getting on the highway, you got to pick up, your acceleration gets bigger because you have to match the velocity or speed of the other cars on the highway already, right? So that's the difference, okay? They're all related. So how are they related? Well, position starts at the top. Velocity is right under that. So the derivative of position is velocity, okay? So it goes by a lot of different names. Position has 2 names, x of t, s of t. Velocity has 3 names, x prime of t, s prime of t, or its name, velocity, v of t, okay? Acceleration has 4 names. It could be the second derivative, x double prime of t. It could be s double prime of t. It could be v prime of t, or it could just be a of t. Either all of those mean acceleration, okay? So on the first page, it's just important info. You might know some of it, right? We used to have physics on this campus. We haven't had physics in a while, but we used to have physics, and this is this kind of stuff you talk about, right? You talk about speed, velocity, acceleration, movement, right? Movement, how things force, right? How do you move things? You need force, right? So that's what they talk about, okay? Newton's 3 laws of physics. I don't know what the 3 laws, I think one of them is something's going to stay in motion until there's a reason for it to stop, right? Something stays in motion unless there's something causes it to stop, right? That's one of them. I can't remember the other 2, but that's kind of physics, okay? We look at the math part of that. So first thing, average rate of change. You guys have seen that before. That's just the slope formula, right? We've seen that before. Slope formula, okay? What are you finding slope of? The beginning to the end. Instantaneous rate of change. Sometimes you're going to see the word instantaneous. What does instantaneous rate of change mean? It means at that moment. At that moment, what is your rate of change? So if you're driving in your car, and you look down and it says 35 miles an hour. At that moment, at that second, that's your instantaneous rate of change. You're going 35 miles an hour, right? Doesn't mean you're going 35 the whole way. You stop, slow down, speed up, slow down, right? But at instantaneous. So instantaneous rate of change is just a fancy word for derivative. What's the derivative at that time? Okay. We talked about derivative of position is velocity. The derivative of velocity is acceleration. So we're going to be looking at derivatives and second derivatives, depending on where we're at. If they start with velocity and they want you to find acceleration, we need to find only one derivative, right? But if you start with position and you need to find acceleration, you need to go second derivative, right? So it just depends on where you start. This chapter, we're not going up. We're just going to be going down. So this chapter, they will never start you at like acceleration and ask you questions about velocity or position. They'll only go down. To go up, we need to integrate. That's what we're doing next semester, okay? So next semester, we'll go up and down. This semester, we're only going down, okay? So position, if they give you position, they might ask you questions about velocity or acceleration. If they give you velocity, they might only ask you about acceleration, right? Those things like that, okay? Let's see what else. Speed and velocity, how are they the same or how are they different? Well, when velocity is positive, it's equal to speed. When velocity is negative, it's the opposite, okay? Because speed has no direction, right? It doesn't matter if you back up in your car. If you're backing up out of your driveway, your odometer will go and say 1 mile an hour, or 2 miles an hour, however fast, right? It won't say negative because speed doesn't care about direction. Acceleration, or velocity does. Displacement. So what is displacement? Displacement is how far you are from where you started. So if I'm here, and I'm here now, I took 4 steps. I'm 4 steps away from where I started. So my displacement is 4 steps away. My total distance is 4 steps away, right? 4 steps away. But now let me do this. 1, 2, 3, 4. 1, 2. What's my displacement? 2 steps. I'm 2 steps away from home, right? 2 steps away from where I started. That's displacement. What's my total distance traveled? 6, because I took 6 steps, right? That's the difference between them. If you're just going in one direction, displacement and distance are going to be exactly the same. But if you're changing directions, they're going to be different, okay? They're going to be different. Like the displacement, if I were to get in my car now and go to east, central east, displacement would be straight line distance. Straight line distance, right? But we don't go straight lines, right? We got to go up, over, up. You know, we have roads, right? So there would be a distance, there would be a difference between the distance and the displacement. So if you look at, like if I'm going to San Francisco, if I'm going to LA, so anywhere, you look at Google Maps, how far is it going to take me? There's always different numbers, right? Depends on the way you take, the route you take. Displacement doesn't do me any good. It's 200 miles to get from here to there. That's great, but I'm not in a plane, right? Even if you were in a plane, planes don't go in straight lines. They kind of go in different directions, right? Distance, total distance is what you want to know. Total distance is what you want to know because that's the route I'm taking, right? Okay. Okay, so you're going to see this buzzword a lot. When is the particle at rest? Particle is anything. Anything. You could be a particle. Pen could be a particle. It's just a thing. Particle is just a name for a thing. Okay, so when is that thing at rest? Well, when velocity is 0. When velocity is 0, that means it's not going anywhere, right? When my car is 0 miles an hour, I'm not going anywhere. I'm staying exactly where I am, okay? When does the particle change direction? So how do you know when the particle changes direction? When velocity changes signs. When velocity changes from positive to negative or vice versa, that's when particle changes direction. When is velocity increasing? So when are you speeding up? When acceleration is positive and you're decreasing when acceleration is negative, right? Doesn't that make sense? If you're going from, on the highway, you're going from 50 to 55 to 60 to 65, right? You're picking up speed. So that means acceleration is positive. When is acceleration negative? When you slow down, right? That's the definition of speeding up and slowing down, right? Speed is increasing. So speed is increasing. So speed and velocity can be different, remember. When acceleration and velocity have the same sign. Speed is decreasing when acceleration and velocity have opposite signs. Okay? All right, because your direction is changing. If your direction is changing, but your acceleration isn't, that's what I mean. And then the last one is the average acceleration of an object is the total change in velocity divided by the total change in time. It can be thought of as the slope of a line connecting 2 points. Okay? This table here is exactly what I read to you earlier. It's just in a table. It's a table. So when are you speeding up? When velocity is positive and acceleration is positive. Same sign. That's what it says right up there. When are you speeding up? When acceleration is negative and velocity is negative. Right? That's exactly what it says up there. When am I slowing down? When velocity is positive and acceleration is negative. When am I slowing down? When velocity is negative, acceleration is opposite signs, right? When am I not moving at all? When both are equal to 0, acceleration and velocity. What if velocity is positive and acceleration is 0? It means you're just going 50 miles an hour and not changing, right? So that's kind of a table. Some people like it in narrative form. Some people like it in a table, whichever one's easy. They both say the same thing. The other thing you're going to see is motion along a straight line. Motion along a line. So they're going to say the object or the particle is moving to the right. What does that mean? Moving to the right means velocity is positive. Moving to the left means the velocity is negative. So just think of a number line. When velocity is 0, that means it's not going anywhere. Okay? It's not going anywhere. So the first page is purely just notes. Just notes. Things to know, because we're going to be coming back to that. You're going to be doing a lot of flipping back and forth, because those are all the questions they're going to ask you. Every question they're going to ask you is based on this page right here. Okay? All right, so let's look at number 1. A particle moves along the x-axis, left and right, because I can only move left and right on the x-axis. Okay? So that its time starts at 0 and gets bigger, right? T is greater than or equal to 0 means you start at 0 and then you start the clock. Its position is given by x of t. Determine the acceleration of the particle at t equals 7. So the first thing, so the question is acceleration, right? So that's the question, right? What's the relationship between position and acceleration?
No, you have to get the second derivative.
Second derivative, right? Acceleration is the second derivative of position. So that means I need to find the second derivative. Okay? All right, the first derivative, 3t squared minus 11t minus 16. What's another name for that guy there?
Velocity.
That's velocity. It's x prime, also known as velocity. They didn't ask us about velocity. So I'm going to keep going.
It wouldn't be negative 22.
What did it? Oh, yeah, sorry, yeah. Yeah, this should be negative 20. Thank you. Yeah, it should be negative 22. Yeah. Let's go another step. Double prime. 6t minus 22. Position's second derivative, also known as
Acceleration.
acceleration, right? Acceleration. So this guy is velocity. This guy is acceleration. So they want to know, what is the acceleration at time 7? So what am I going to do next? Plug in 7. Plug in 7 into my acceleration function. So we get 42 minus 20 equals 20, 22? No, wait. 42 minus 22, yeah. I don't know where I write 20. Should be 20, yeah. Now, they didn't use units there. There's no units. What is time? Minutes, seconds, hours? I don't know. So we don't use units. Sometimes they will use units, sometimes they don't. Okay, and we'll talk about units when we get there, but yeah. Okay. So the velocity at time 7 is positive 20. Okay. Let's go to example number 2. Everything we do in this lesson, you've done before. It's just under a different, we're using different verbiage. We're not using f prime of x, g prime of x, g double prime of x. We're using position, velocity, acceleration. So the biggest thing is to know these guys here, where they fit, okay? Everything we're gonna do today, find the second derivative, plug in 7. You guys have done before. You guys have done all that before. It's just using the physics lingo, okay? All right, so a particle moves along the x-axis, so that time is positive. Starts at 0 and it goes positive. Its position is given by x of t equals t cubed plus 6t squared minus 36t. Determine all values when the particle is at rest. When is, so this is the big one right here, because this is the part that's new, right?
When it equals 0?
When what equals 0?
Velocity.
Velocity.
There you go, right? It's written in the front. Boom, right there. When velocity is 0, or it's written up here. Particle is at rest when velocity is 0. So we have to find velocity and set it equal to 0. Right? So what do we do to find velocity's function? What do we have to do? Get the first derivative. You can call it v of t, you can call it x prime of t, it's both the same thing. So it's 3t squared plus 12t minus 36. That's velocity. It's the same thing as velocity. Set it equal to 0. It's a trinomial. So if a trinomial, GCF, I got a GCF of 3, so I can divide everything by 3. Then you can use your little x here. So what multiplies to be negative 12 and adds to be 4?
Negative 2, positive 6?
Negative 2, positive 6, yeah. So we got t minus 2, t plus 6. Find the zeros, find the values. What numbers in there would I put in there to make 0? What values would I put for t to make 0?
2 and negative 6.
2 and negative 6. 2 comma negative 6. So I put 2 and negative 6. Here's the question here I'm going to ask you. This question, you'll see, if it was a multiple choice question, this is what they would have. None of the above, yeah, none of the above. Which one would you pick, A, B, C, or D? It's not D, I'll give you a hint, it's not D. Why is it C, just C?
Because it has to be greater than 0.
Yeah, time has to be greater than 0. Can't have negative time. Never have negative time. So if you ever get anything with a negative time, t equals a negative something, nope, doesn't work. Time can't be negative. Can't go backwards in time. Not that I know of. Time always moves forward. So we're not going to use anything with a negative 6 in there. Okay. All right, let's go to example number 3. All right, so particle moves along the x-axis. That's when you see that verbiage, when a particle is moving along the x-axis so that time is greater than or equal to 0. That's usually a sign that it's going to involve position, velocity, and acceleration. It's usually a sign that we're going to use this. Okay, so x of t is negative t squared minus 8t minus 23. Determine if the particle is moving left or to the right at this guy. How do I know when the particle is moving right and when the particle is moving left?
The velocity, if it's positive or negative.
There you go, right? If velocity is positive, it's moving to the right. If velocity is negative, it's moving to the left. That's written right there. So what I have to do is figure out where velocity is positive and where velocity is negative. That's what I have to do. Or, because all they want is 5, right? They don't need to know intervals. They're not asking for intervals. They just want to know at 5, is velocity positive or negative? So how do we do that? Find velocity's function. Velocity's function is going to be the first derivative of position. Negative 2t minus 8. First step. What's the next thing? Plug in 5.
Get negative 10 minus 8, which is negative 18.
We get negative 10 minus 8, which is negative 18, right? So let's answer the question. Is it moving to the right or moving to the left? It's moving to the left, so let's write this down. The particle is moving left because, oh, sorry, I should put at time. At t equals 5 because, how did we know it was going to be moving to the left?
Because
V of t is
negative?
So v of 5, right? V of 5 is negative, right? V of 5 means velocity at 5, yeah, is less than 0. Because some numbers, if I were to plug in a negative number, well, I can't plug in a negative number. But if I were to plug in pretty much everything, right? Everything, any number I plug into v of t is always going to be negative because I can't plug in negatives because time can't be negative. So pretty much every time velocity is going to be negative for this guy. All right, let's go to number 4. Particle moves along the x-axis. Position is given by, determine all intervals. So now they want intervals. When the speed of the particle is increasing.
That would be when acceleration and velocity have the same sign.
There you go, right? When acceleration and positive, when acceleration and velocity, so when is speed increasing?
When velocity and acceleration have the same sign.
Same sign, right? Either both be positive or both be negative. So let me write that down before I start. So 2 situations. When v of t is positive and a of t is positive, or when v of t is negative and a of t is negative. Either one of those has to be true. So how do we show when velocity is negative or positive? We've done it before. You've done it on a quiz. We've done it, definitely did it in class.
Find the derivative,
So why do we find the derivative?
because we're looking for velocity,
And they've given us
the base,
position, right? So what does it call when we need to figure out if the first derivative is positive and negative?
increase,
First derivative test. So we're doing the first derivative test. So the first thing we have to do is do the first derivative test. That'll tell us when velocity is positive and velocity is negative. So let's do v of t first. First derivative test means we need the first derivative. So the first derivative,
4t to the third minus 36t squared.
4t to the third minus 36t squared. How did we do it a couple weeks ago when we did first derivative test? What did we do next? Set it equal to 0. It's a binomial, so we're going to factor out whatever GCF we can take out, so 4t. So it's going to be t squared minus 9.
You can't take out t squared.
Oh, sorry, yeah, I did take out t squared, and I didn't. There we go, yep. T squared because they both, yeah, definitely t squared. Set them both equal to 0. 4t squared equals 0. T minus 9 equals 0. What does t equal?
0 and 9.
Okay. Then what did we do after that?
Plug them in.
Number line.
Number line. Yep, number line. So we need a number line. We're going to put both of our 0 and 9. Then plug in things to the first derivative. So what kind of numbers do I want to plug in?
Small,
Like what would be a small?
like negative 1, 1.
No, not negative. Why would I not want to plug in negative 1?
Because time can be negative.
Time can't be negative, so we're not worried. So this guy is not actually exists. It's not actually a line, it's more of a ray because it only goes in one direction. So definitely between 0 and 9, definitely bigger than 9.
So 5 and 10.
5 and 10 work. 1 and 10, whatever you want to pick, just trying to see if it's positive or negative. One. 4 minus 36 equals negative 32. So between is going to be negative. Okay. If I plug in 10, 10 cubed is 1,000. Times 4 is 4,000. 36 times 10 squared, sorry, it should just be squared, 3,600. Subtract, I get positive 400. Okay. Decreasing from 0, so velocity is decreasing. I'm slowing down from 0 to 9, and I'm speeding up or velocity is velocity is negative. So I'm going left from 0 to 9. And then I change direction to go right after 9. That's what that means. Okay. All right, so now we need to do second derivative to figure out where they're the same and where they're different. So second derivative test. Okay. Oops, I need the second derivative. Second derivative is 12t squared minus 72t. Okay, same thing, it's a binomial. 12t is the GCF, so I get t minus 6. So I get 12t equals 0, and I get t minus 6 equals 0. So what are the two going to be?
0 and 6.
0 and positive 6. I'm going a little faster because we've done this many times. You guys can do the first derivative test and second derivative test. Again, since t is time, we don't have to worry about anything less than 0. Don't really care about anything less than 0 because t can't be negative. So again, it's not actually a line, it's more of a ray going in one direction. Okay. So the second derivative, you pick the same numbers, you can pick different numbers. I'll pick the same numbers. 1, 12 times 1 squared minus 72 times 1. I get 12 minus 72, which is negative 60. Negative. I'll pick 10 again. You don't have to pick 10. You could pick 7, 8, 9. 12t squared minus 72 times t. T squared is 100, times 12 is 1,200. 72 times 10 is 720. That's going to be positive 480. So I'm slowing down, I'm losing velocity at 0 to 6, gaining velocity 6 after 6. So the question said, when are we speeding up?
Overlap the number line.
So yeah, so we're going to overlap the number lines. You can create a new number line, or you can just use the old number line. If you're good at the spatial visual stuff, this is what we're trying to do. We got 0, we got 6, and we got 9. So from 0 to 9, I have negative. From 0 to 6, I have also negative. And then after 6, I have positive. And after 9, I have positive.
So it's increasing at 0 to 6, and now we're at positive.
So yep, exactly. Where is the same sign? Well, same sign. We have two. We have both negatives. There. And we also have both positives there. So we answer the question. Make sure you answer. That is not enough to answer the question. Answer the question for someone who's doesn't know anything about this, you gotta see what you found. You gotta put into words. So speed is increasing from 0 to 6 or 9 to positive infinity. Justification. Because v of t and a of t, acceleration and velocity, have the same sign. Anyone who's reading this knows exactly what you meant. Why is it 0? Where is the answer? 0 to 6, 9 to positive infinity. Why? Because they both have exactly the same sign. V of t, what is it? Because they, what is they? V of t and a of t. Okay. So all of these are just going to ask you different questions. They're going to say things like, we've seen, when is it moving to the right? When is it moving to the left? When is the particle? When is speed increasing? When is the particle at rest? Things like that. Those buzzwords that you're going to find on the first page. Okay? Okay, so the next thing, we'll do the first one because these don't take very long. The next thing is graphs. Sometimes they won't even give you, they give you a graph. The first thing you got to do is, what graph is it? Is a graph, what is the graph representing? So we have 3 different things, right? We know it's time, right? It's always going to be time. X is always time. But what is y going to be? Is it the position? Is it the velocity? Is it acceleration? It's velocity, right? This one's velocity. So it's velocity and time. In other words, we're looking at the first derivative graph. This is the first derivative graph. Okay? That's what we did earlier last week. That's what we did last week when we were reading graphs. A particle moves along the x-axis so that its velocity goes from 0 to 18. Starts at 0, goes to 18. Is given by v of t, whose graph is shown below. The inflection points are marked with green circles. They're not green on yours, but you should see a little circle, the little circles there. Those are just where the inflection points. What is an inflection point? What does it mean by an inflection point?
Is it like the point of change, like where the green points are at, kind of?
Yeah, what is it representing? Yeah, how did they know those 3 spots they circled are the inflection points? Oops, what the heck am I doing? How did they know those were the inflection points? Have we been asked that question before to find inflection points on a first derivative graph? We have, right? Find the x-coordinate for inflection points, right? And how did we do that?
When the second derivative is equal to 0?
That's the reasoning. That's the justification. But how did we know where to find them?
When the slope of the graph is positive or negative?
When the slope of the derivative graph changes from positive to negative or negative to positive. That's how we know those are inflection points. So those are inflection points for the original. Okay. Of the graph are marked in green circles. Find all intervals when speed is decreasing. When is speed decreasing? I'm not asking you the answer to the question. I'm asking you, where the heck do I look? Where?
When
When
velocity,
y is negative?
when velocity and acceleration don't have the same signs.
There you go. Right there. When speed is decreasing when a of t and v of t have opposite signs. So you're looking right here and right here. Or you're looking right here. When they have opposite signs. Okay. Anytime you have a question with this, 90% sure the answer is going to be somewhere on here. Or if you're stuck, that's where I would go. First page, the very, very first page. Okay, so we have to figure out where this is positive and this is negative, or this is negative and this is positive. Either one of those will answer our question. So let's color code this thing. Let's start with velocity. How do we know when velocity is going to be positive looking at the graph?
When it's above the x-axis?
When it's above the x-axis. It's the velocity graph. So when is it going to be positive? When it's above the x-axis. So there is positive, there is positive. Okay. Velocity, positive. When is velocity negative?
When it's below the x-axis.
When it's below the x-axis. So between 1 and 11, and then from 16 to 18. Oops, did that wrong. Did that? Okay. When do we know where is acceleration positive and where is acceleration
We have to find
negative?
the second derivative,
No.
or the derivative of this.
Okay, but help me on this. Help me on this. How do I find where where acceleration is positive and acceleration is negative? Slope of this guy, right? So when slope of this guy is what?
Negative?
So what does that mean? Slope of this guy is negative.
Slope is negative, it's
So what does that mean though?
concave.
When it's decreasing. There we go. Decreasing. Okay, so decreasing. So it looks like it's decreasing from 0 to 8. If it's decreasing, what does that tell me?
That it's negative?
Acceleration is negative. And then it looks like it's decreasing after 12. Or sorry, 13. And it's increasing between. So now let's answer the question. Where is speed decreasing? From 0 to 8, because
Would it be 0 to 1?
so what are we looking for though? What are we looking for? We're looking for yellow and less than. So where is yellow and less than? 13 to 16 and 0 to 1, right? 13 to 16, 0 to 1, or 0 to 6, or 13 to 16, right? Now the opposite, pink and greater than. Where is pink and greater than? 8 to 11, and that's it, right? Okay. All right. We'll continue when we leave where we left off on tomorrow.